about the circuits on it, and we're going to take a look at Mike's design and what he's got going on his. Mike, tell us a little bit about the motor you built.
Uh, it's just a Bedini motor, the standard one, SG. Or are you talking about the most recent one? It's a little different. The other one.
Just the one that you told us about before. I know that we looked at together one that looked like the window motor we talked about with the
Yeah, that's
standard
different.
coil around it and the
Hmm.
magnets in the middle. And the other one you talked about a wheel. Was it the bicycle wheel one?
Yeah, the one that I've replicated by Bedini is the standard Bedini SG. It looks like a bicycle wheel with magnets on it, and I can bring up the circuit uh, right here. Let me bring up the circuit here.
While he's bringing that up, guys, I'm excited about this because we have some energy spikes in here that I want to go over with Mike, and because he's built it, I want to see exactly what's going on in it. So
Did you have it?
it's going to be really cool. Okay, here we go. Here's the circuit. Let's put it up there. What do we got going on?
So this is your standard Bedini SG pulse motor, sort of like a pulse motor, but different, a little different. Um, which one is this? Oh, hold on, I brought up the wrong one.
It's
Let
okay.
me see. I'll bring one off the. Yeah, let me bring up the right one. Hold on.
Oh, bring it in. We'll check it out.
It looks like this is the non-solid state one, right? The little moving
Right.
coil.
Bedini SG circuit. Open this. Okay. See, there it is. Okay, that's the one.
That's the one. Okay.
So that's the basic circuit. See here. Okay. You can see the blue marking. Okay. Yeah. So here is your source battery, and
Okay.
here's the charging battery,
Charging battery. Okay.
and this is the coil that you're going to charge up from your source battery. Um, and when the transistor closes, it'll charge up to the
We're using
circuit.
PNP or NPN.
It's NPN.
Explain to the audience the unique situation where the diode is actually feeding negative energy.
This diode?
Yeah, isn't it feeding it backwards into the battery?
Yes. So let me explain that.
Yeah, that's
Because this
fascinating.
this is not, you could be a technician or whatever. Unless you fully did the research before you built this, you're probably not going to understand what's going on. So what happens is the coil receives a plus right here from your battery, from the charge battery, right? See it? This is your plus from your charge battery,
Okay.
okay? And it will place itself right here on the coil, plus, right? And then the negative will, when this transistor gate closes, the negative will appear on the other side of the coil, right here, because it's over here, right? And now you're placing a negative and a positive on this coil.
Hold on. How did it get the negative through the switch?
Oh, because you triggered the transistor to close the gate and all the negative in. So let me go back a little bit. So this is the base of the transistor here, and this is the trigger winding, right?
Yes.
which is like a gauge 28, a little thinner. This is like 26 right here, about 150 feet of each.
Are they
So
separate?
when you
I
say
thought they were
trigger,
Yeah, no,
winded together.
they're wound together.
when you say
Like a
trigger wire,
bifilar.
is that the pickup wire, or the wire that you're inducing with?
Yes, that well, they're wound together. Both these are wound together in a
Oh, that's right, they're
bifilar.
bifilar.
Right. So this magnet here, when it ends up around here, it's gonna and there's a core inside here, iron core. So it will, when this magnet ends up around here, it will charge up really both the coils, with magnetic field from the magnet. But the only coil that's going to matter, this is that magnetic field from the rotor magnet hitting this coil is not going to do anything because it's just not going to. But it's going to hit this coil, also and give it about 2 volts, and it's going to send the 2 volts to the base of the transistor. This will be the positive side of the 2 volts from the trigger winding. And this is the negative side of the trigger winding 2 volts. So the negative, the positive, goes this way. It's the base. The negative goes this way. It's the emitter. Triggers the base like that, closes the gate, allows this negative here to touch here on the coil. And of course, this positive is already touching. Okay. All right. Was that too fast? Was I too fast there?
No, go ahead.
No,
We're good.
no.
We're right in line with you.
So that's basically an oscillator. You're just switching on and off the transistor with the magnet on the wheel.
So
Passing
basically,
over
just
the
that switching action
trigger
is
coil.
creating the oscillation.
Right, the trigger coil is creating the switch on the transistor, but you see that how the running battery is hooked up to the coil on the positive side already, and the negative side has got to go through the transistor to be
So
connecting.
would you say the switching action of the transistor is like taking the place of a function generator, shaping the signal, pulsing it or whatnot?
The switching action is just going to turn it on and off, and that effect is what it takes to generate a radiant spike, is to turn the switch on and off. That's all
And
you have to do.
isn't that what a function generator does, like in a square waveform? It's just turning it on and off at a certain frequency?
Well, a function generator has like capacitors in there to create square waves and keep the line up a little longer before it drops. And they have circuits to shape the signals the way you want them. This circuit is designed to shape the signal like a flyback signal, like a radiant flyback signal.
Oh, okay.
So the
it's still
resistor in
shaping.
there.
Yeah, because there's no capacitors to actually keep the voltage up or do any shaping like that. There's no capacitors in this circuit, but there is a inductor and a switch, and that's all you need to create the flyback event, is to turn off the switch. Every time the switch is turned off, this event happens, no matter where the switch is or what it's hooked up to. And this is why, the old TVs used to blow out. The old tube TVs, they had transistor tubes in there, and when they would turn off the TV would blow up.
The cathode ray tubes, yeah.
Okay, so
very
real quick,
common.
Mike, real quick, the resistor. I want to get to this part on the resistor before we get to the transistor. And I believe he said 830 ohms is where you started. Can you please explain why it's 830 ohms based on what the magnets are?
830 ohms?
Yeah.
On
the resistor going in before we get to the transistor.
Oh, okay. Yeah, that's just to limit the current on your trigger signal coming from the magnet right here. The 2 volts coming from that hitting here has some milliamps to it. Not a whole lot, but then again, keep in mind as this wheel spins faster, that those milliamps go up. So having a potentiometer here, you can turn down the milliamps so that the strength of which the switch closes is a little weaker. So the more milliamps you give the transistor at the base with your voltage, your 2 volts, the stronger the contact will be. So that makes a difference in all these effects, you know. If you have a very weak contact and brief, as opposed to a very strong and firm one, all these things matter.
Okay.
But anyway,
I was wondering about the heat.
You can tap really fast and by not touching very strong, you know. So that's by limiting the current with these resistors right here, you know.
I was worried about the heat. So when I watched
That's
Bedini
100
say it
ohm.
about it, it was the reason the resistor was so low is he wanted to reduce the heat because he wanted to keep it mostly potential when he had the magnet come over the coil and he put the rods
Right,
in
I
it that were
believe that
welding
those
rods.
resistors limit the duty cycle from being, you know, too long. They
Gotcha,
limit
but
the current, so the less current going through, the longer the switch stays down.
Right, but the less heat that the circuit gets is the less amps.
Well, this is just
Less
a
current.
trigger signal, so it's not really handling much amps. This whole circuit here, where is it? Sorry, let me go back. Right here.
Okay,
This part of the circuit.
let me just explain why. He explained when you take the neodymium magnet and you put it in there, it takes the core of the actual coil, and what it'll do is it'll heat it up because it puts too many eddy currents in it that cannot get out. That's why they use the welding rods in order to disperse the heat. Then they put the resistor in the circuit to make sure that you don't have overdue heat in the circuit with amps. So based on that, when it flows through to your transistor, it's now potential instead of an actual AC voltage. You're getting pure potential through it without the heat, without the amps.
Right. Well,
That's why I bring it up because
that's the coil that handles the amps right there.
Right. It's going to matter when you go put it past the transistor into the diode before it gets to the battery. Because that's where it's going to make its special H wave.
Wait, what's an H wave?
It's basically like you see like a molehill or a sine wave on the top, okay?
Mm-hmm.
And it looks like an N, except for the N part turns into an H part when you get a spike. So you basically have 90 volts that comes through the system, right? And then at the very top, it goes from 90 to 300 is the way Bedini described it. Therefore, you get a spike in the voltage at that point. And then the spikes, he keeps adding those up. And that's what's going into his battery to charge it so fast.
Right, but all the amps are going through any kind of amps are coming from the drive battery, and it's going into this coil alone.
Well, we know about just by shaping.
I mean, the drive battery is isolated from the trigger, so this is just a low current, low voltage trigger signal. That's all the trigger winding is doing. But all the amps are going in here into the other coil. And yeah, if there's resistance, you got a bad battery or something, it will heat up this coil, the drive winding. And I don't know about this one, but it'll heat up this one, and it might, you know, damage. I don't know, it might harm the transistor. I mean the diode.
Have you actually attempted to build one of these?
This circuit here, I've built over a dozen of them.
Is that what we see in that video that you sent us?
No, that's a different one. That's based off the Newman's setup.
Okay, let me add a video to this so we can look at it. I just want to look at it with you.
Okay.
I feel that
I'm not sure which video.
I've probably said this 1,000 times.
So
taking the degrees, not.
Here's what I'm going to do. I'm going to set this up for you. and he talks about why he does certain things. And you just tell us what's going on here. So,
Okay. Yeah.
Okay, that's a good idea.
That is basically currentless. We don't want any current. We want the current to build in here, but we want to shut this current off. We want this current to build a magnetic field, but we're going to shut it off right away. So, what we want to do is we want to use just a basic NPN transistor. And of course, in this loop, this is the ground.
You want to pause it for a second? I got something
yeah,
to say
absolutely.
here.
So-
Here we go.
Right
Go
where he
ahead,
is
Mike.
at the bottom there, you see the ground where they. Well, that's the battery negative also.
Okay. Yeah, I imagine all the grounds going to one, so it'd be, be technically one line.
Right. So the transistor is going to close and give you the negative. So on the
Right.
top of that coil is where the positive is jumped already.
Right. And it
So
was,
he's going to switch the negative to energize that coil. But by switching the negative, I see he chose to switch the negative because it's negative energy. What other reason? It's behind the zero line energy. It's the negative zero, negative one, negative two, negative three, like metric. It's that.
this is the reason it gets a special effect. This is why I get excited about this motor. So let's watch a little more and tell me where to stop.
I mean, you could switch the positive or the negative. Yeah, but
We know that we want to connect the battery. And we'll just put that one to ground. These two grounds match. So just think of a line between them. Okay, the next thing that we want to do is we want this wheel. We're going to move these magnets. So if I move these magnets, we want, when the wheel moves, we want this magnet to be attracted to this iron. Now, as this magnet, which has a field around it,